Hi. Welcome to Berg Mountain Optional University's #calculations for tomorrow, Tools in Mathematics 6 and Chapter 5's Approaching a Mastery in Geometry. Won't you come along with us?
Chapter 5, Epsilon, V. Approaching a Mastery of Geometry. From perfect four-sided squares manufactured first in minds we proceed to the number 5 and pentagons, explore multiple-sided shapes and approach a mastery of geometry in the world. With our eyes we perceive masses of colors where over time learning to maneuver our bodies to investigate what once distant becomes closer where shape may be distinguished. Though color is not the issue in this session, it should be noted that color is recognized prior to shape, because from shapes light is reflected where the moon is a grayish hue. Seeing in the sky not a circle or sphere, the moon like the earth is only circular and spherical. The main point is that we see matter in the world taking on some type of form of which things formed. We sum up in communication generalizing them as geometrical, when imperfect though thought in minds. The suffix metry alludes to the science, process, and even art of measurement whereof what we consider things seen correlating them to concepts in the mind called geometric. What are things other than straight, curved or crooked, and what do we call 1, 4, or 5 others than things in the world? The prefix geo derives from the Greek upsilon eta or upsilon alpha iota alpha, meaning earth is personified in the mythological goddess Gamma, or Gea, gamma alpha iota alpha, who parthenogenic, reproducing asexually, was from whom all life was born. Without the law of man geometry would neither be, but separating what's human from nature, like bees' hives, we manufacture floors flat, walls perpendicular, and ceilings parallel to floors. In space man resides in some type of shape. Things we distinguish in the world are generalized in minds as shapes where first-order logic was by Euclid to the Western world defined as geometric, with which Freemasonry expounds on today. Things we distinguish in the world from others are generalized in our minds as forms that matter takes imperfect or more perfectly manufactured in space as shapes.
From points, lines, ellipses, and parabolas to distances and angles, surfaces, planes and curves are concepts fundamental to understanding shapes in space. Graphical representations of objects distinguished from others are so by boundaries which take form in some type of shape two-dimensionally on paper and three-dimensionally in the physical world. Distinguished from their orientation, scale, location, material, color, reflection, or texture, shapes are figures representing some type of measured size. From circles, one-sided, and triangles, three-sided, to quadrilaterals, four-sided, pentagons, five-sided, and other polygons two-dimensionally measure are in squared space while three-dimensionally cubed in volume. Not that dimensions of space hadn't been known in nature, through architecture, or from other things manufactured previously, but we think it pertinent to note research of space in more than 3 dimensions by the Swiss mathematician Ludwig Schläfli. Geometers, mathematicians working in the field of geometry, have understood the fourth and further dimensions from Schläfli's work posthumously published in 1901. Writing Theorie der Vielfachen Kontinuität, Theory of Multiple Continuity, by 1852, he's known for the development of regular polytopes, Schläfli's graph, his double six, his symbol and his ortho scheme.
Seeing things in the world we associate perfection in shape where Euclid defining first-order logic to the Western world did so in synthetic geometry. Known as the father of geometry to the Western world, of course, Euclid, though little of his life is known, lived, and practiced in Alexandria before Archimedes. In his 13-book mathematic treatise entitled Elements in 300 BC, Euclid defined, postulated, proposed, and proved theorems from simpler axioms. Deducing things as either P or P, much of his information presented in Elements was already widely known, but the first in the Western world to compile geometry in a logical system, Euclidean geometry, was so born. In his textbook Euclid explores plane geometry, number theory, and solid objects geometrically. Books 1 to 4 and 6 discuss shapes on two-dimensional planes. Books 5 and 7 through 10 cover prime, rational, and irrational number theory. And in books 11 through 13 he covers solid geometry, where constructed therein are Platonic solids. Using no more than a compass and straight edge, Euclidean geometry being constructive allows the existence of certain figures and their uniqueness to be proven.
Differentiated from synthetic is analytic geometry, using Cartesian planes where not merely in theory were shapes bound to points, and masonry, though still secret, was better grasped. Why? Well, because though wanting to be kings and queens few could comprehend the magnitude of administration until quartered by an x, y axis and focusing where points were all positive, northeast. Why? Well, because negative numbers south and west were not only misunderstood but impossible. Why? Well, Masons travel eastward because to the west was the Atlantic Ocean and the South Africa, and it's also one reason why we write from left to right, but this is geometry. Manufacturing shapes and spaces in the world, the practice of Freemasonry results in buildings today as men reproduce mind's geometric perfection physically and artistically, separating man from nature. From physics and engineering to aviation and spaceflight, modern fields of this mathematic study and practice are founded using analytic geometry. Algebraic expressions where corresponding numbers and points on lines of planes result as mathematical logic from a thesis termed the Cantor-Dedekind axiom. It is significant because in the evolution of mathematic understanding since ancient times and even to today, the common man seldom outside of age counted past their own distal phalanges. Squaring, cubing and other powers just pasted by comprehension, where on a need-to-know basis architects knew, craftsmen understood, and common men rented ideas manifest in the world they would never understand. And so, architects make perfect leaders.
Shapes are generalized objects we distinguish from others of the world in our minds, where the father of geometry, Euclid, defined parameters of the Western world which Freemasonry expounds on further today. While 2- and 3-dimensional objects are common understanding, fourth and higher dimensions are explained in Schlafly's posthumous work. And mastery of geometry is proven in architecture.
That's all the information we have for you this session. We hope you are closer to mastering geometry. Next session we cover using shapes to represent geographical ideas. We hope to see you there. Thank you for your time and consideration.